Okay, so continuing further, now we are into network security. Okay, so just a recap that last time we started to understand what is network, then what are the communication points, what are the different type of networks we have. So we already know that internet has been evolving continuously, and nowadays internet is into above fourth generation, and fourth generation includes IoT and other devices also. So now there is a need of lot of network management, lot of network security. Because every device is now getting added into the network. As we talk about the smart TVs, smart fan, smart um, kitchen, everywhere. So IoT is another new era which has joined the race into the internet evolution. We talked about OSI model, which is of 7 layer. We should not forget, we should always remember this. And many other protocols, many other models are based on this only. So uh, lower models are like hardware. So you should have some hardware for that. And then there are the protocols. So whenever we go for any kind of communication, or any kind of data transfer, or any kind of device which is taking part in the network, all those should have this compliance to this OSI model. So there are different other models also. So how network security is very relevant. So network security defines these areas, and we have to understand these areas, and we should go along with this network security in these object with these objectives. So very first thing is I'm going in clockwise. So this is antivirus and sandboxing, which is giving a uh, secure isolation, which is creating isolation, and because of that we can be saved from the any harm which is coming from the internet. Then remote access, VPN, IBS, web DNS, firewall, NACL, and attack surface management. So all these we are going to also uh, get in detail as we proceed in other topics as well. So we talked about that, and then we know that OSI model is can be borrowed and modified for the internet, and they are called as TCP/IP model. So then TCP/IP model is there. After that, we also talked about three-way handshaking. That how in TCP, whenever any network is starting, so it should start with some sort of agreement, and that is called as three-way handshake. So we should know that three-way handshake also. So that part we, is it visible as full screen now?
Yes.
Okay, okay. So whenever any client wants any access from the server, very first time it sends a sync signal. Sync signal is having some slanted because of time delay, and it is received at the server, and then sync plus acknowledgement is being sent to the client that we are ready to start the transfer or communication, and then sequence number will be received and acknowledgement will be received from previous sync plus 1. If sync is to be given for, let's say there is a sequence number of 10, then acknowledgement will come as 11. So always understand acknowledgement comes plus 1 from the sync. So all these are things there as a basic networking part. And some PDF book is also being shared with you all, so you can go with the first 3 chapter. Just check the contents, what are the terminologies used there. That is all. That is purely for the network. But as a network security, which is also part of cyber security, we must know how networks are configured and what are the terminologies in the network. And then acknowledgement is finally again sent, that I have received this server's acknowledgement as well, and now we can begin the data transfer. So from here data transfer will begin. So begin the transfer. So that is called as three-way handshaking. That is for establishing the connection. That is also there for the terminating the connection. Okay. So these things are available. Okay. So these parts we did even in the last time, and now we'll move further. We know that there are some threats and we need to take certain measures. So how do we take the measures? All these things will get more clear as we go chapter by chapter, because these are the common things. This is the header format for TCP and UDP, which is present in the transport layer, and transport layer is responsible for creating connectionless or connection oriented communication in the network. So for that we can refer this. This is not directly relevant to us, but it is there that we can. And then we have one activity where we want to understand that how can we monitor the network. So for that we are using Wireshark as a software, or as a, it is open source tool. Okay, so we can check the demo as well. But before that I'll just go with the last time I just discussed the IP addresses. So today we'll just go about basics of IP address. Then we'll start with the pinging network, and then the tools which are helping us in the network securities. Okay. So first thing is about to understand the IP address. So what is an IP address? IP address is nothing but a internet address. So whenever you connect via any device, you always have architecture of the internet. So in internet, every device should have an IP address, and this IP address can be of two types. One is called as public IP address, one is called as private IP address. We'll go in the detail. And then furthermore, the IP addresses are of their technically are of two types. Nowadays we have IPv4 IP address version 4 and IPv6 IP address version 6. So now let us understand what the IP is, how IP is assigned, how the communication is taking place through the IP. So that will give us brief understanding how attackers can go and they can do some exploit or do something. So all these things can be understood here. So before proceeding further, like I just want to know that do you all know what is IPv and what is IP address and how is it given or resolved? So uh, last time we just talked about something called as DNS. So that was domain name service. So domain name servers are set up, and whenever you try to type any web address, so DNS resolves its IP address. So a general process is what? If you have a console, you are typing one web address over here. So this web address will be taken further, and it will, because user is addressing giving this web address, and web address will be given to DNS, and DNS will generate what? It will generate the, it will guess the IP address of that, and IP address will be reverted back in the place of web address via DNS. And then once your browser gets the IP address, like say if I have google.com, then later it will be replaced by some IP address, and then from that IP address your internet or your data packet, your connection can be formed, and whatever is there onto that IP address, let us talk, let's say there is a web or scripting format is available. So you have created one script, and in that script now you are having one home button and orientation. So it is up to the writer that how when script is running, then how visually you have created that attractive, you have created that website. Okay, so websites are nothing but written into the various scripts. Okay, so how does IP address look like? So IP address is actually denoted into dotted decimal form. So whenever we talk about IP address, it is denoted in dotted decimal form, because this format is very much easy for the students to understand. So whoever is trying to go with uh, IP addresses, we can represent it like 15.6.7.5 or 0, but this 15 is actually one 8-bit number, 8-bit binary number. 6 is also 8-bit binary number, and 7 is also 8-bit binary number, and 5 is also 8-bit binary number. So if I add all four, 8 plus 8 plus 8, it will become 32-bit of binary address. So binary addresses are only work, means they are on actually used by the computer. Okay, so binary addresses are important. So let's talk about, if I have 1101101336 plus 1 in this dot, let's say 8 times zeros, then there is again 8 times zeros, and then there is 8 times ones. So this is how IP address is actually seen or present into the computer in binary form. Computer or network devices. But for us, it is very difficult to pronounce, very difficult to understand, because in the network we have to do architecting. So we have to decide which network or segmentation is there. Various other techniques are there by which we assign the IP address to our resources. Am I audible properly? Just checking. Is it visible, the white screen?
Yes, it's visible and you are audible.
Okay, then. Thank you. So binary number is used in computer, which is having bi means 2, 0 and 1. Whatever in this word you want to define, just define with this two thing, 0 and 1. So it includes number from 0 to 9, capital A to capital Z, small a to small z, and then all these special characters. So all these things will include if I'm talking about English. Okay, if I'm talking about any other language, because like Korean, Russian, if other language, then the mapping is available actually. So there is a body which is American National Standard Institute, and ANSI has developed in 1970s around ASCII characters. ASCII. So ASCII code is this. So everywhere there is ASCII. So capital A is in that table is written with the 65 number. So whenever you type capital A from keyboard, actually it is given understood as 65 in the ASCII table. And now 65 will be converted into the binary numbers, and then this binary number is represented like this. So in IP address also it is happening. So IP address is also into binary, but for human or for understanding for architecture purpose, we represent into dotted decimal form. So dotted decimal form says at every 8 bit you just put one dot there, and after that you write their equivalent, this 8 number ka equivalent. So how means you have to convert this binary number into decimal number. So there is lot of converter, online converter, even in our calculators, and various methods are there. Just increase 2 ka power, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 5 up to 2 power 8. So 2 power 8 whatever is there, plus this plus this plus this plus this plus this plus this plus this. So if I add them all, it will become 2 power 8 because all are ones. So there that answer will become 256. So remember, if all ones are there, it will become 256. If all zero is there, for this 8 number of zeros, my overall equivalent in decimal is coming this. Decimal number is what? Which is we are using in our daily life, which is 0 to 9. 0 to 9. 0, 1, 2, 3, 4, and all the other numbers are actually made of this 0 to 9. Similarly, for this also we have dot 0, and for this we need to calculate. So double one zero double one zero double one, what will be this? So that we need to check on. Okay, so we can calculate it actually. 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7, and we need to write the equivalent. So whenever wherever 1 is there, that is valid. So 2 power 7 into 1, so that will become 110 110 11, binary to decimal I want. So that becomes 219. So we can also, if we want, we can understand, like we can take up this task and understand how can we get. So 219 is the number here, again dot. So this is what is called as IPv4, IP version 4. So it is IP address actually. So this is the IP address which is given to every network or every device, network supporting device. Thus device right from Bluetooth, Wi-Fi, Zigbee, or any smaller device, IoT device, computer, desktop, laptop, laptop, mobile phone, everything is using this IP address. So network supporting device must have an IP. So this is required. So this is our requirement here, that we did, that we should have an IP address. So this is at very basic form I have explained about the IP address. We can also read more whenever we want. So our every investigation or every security, everything starts from this IP address. So that is why we should know what is an IP address. And there is no start and end of the IP address. From today onwards, you have just got to know what is IP address. Then also it is better. Okay, no problem. Okay. Now, second address that we need to know is called as MAC address. MAC address is actually a short form for Media Access Control abbreviation. So MAC address is actually what? It is an unique number which is made by the at the time of manufacturing of the device, and that number is embedded or in the hexadecimal form. So this is another number system which is called as hexadecimal form. hexadecimal, hexa means 6, decimal means 10, so it will become 16. 16 is so the base is 16 now. So if I want to like represent get hexadecimal number, so their number starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But I can't go 9, 10. Why? Because 10 is a combination of this number which is between 0 to 9. So that is why we cannot go with 10 number. So that is why they decided to take another new variable name which is called as A. Now A means 10, B means 11, C means 12, D means 13, E means 14, and F means 15. So if I say 16 numbers, it is from 0 to 15. So total count will become 16. So number is from 0 to 15. Whenever I say any number, if I say binary, binary means 2. So number will go up to 1 only, 0, 1. Always start from 0. If I say octal number, octal means 8. So number will go from 0 to 7 only, not 8. So when I say, so only you should know only these two: decimal number, binary number, and hexadecimal. So all these are like very small basics that what is there. So I just gave you the brush, little bit brushing about what is number system. So we are using binary number in our IP and the hexadecimal number into the MAC address. So that's all. So MAC address is always represented like this, and it is the physical address also. Sometimes it is also called as the physical address. So physical address, MAC address, they are nothing but the 12-digit hexadecimal number which is into 6 form pair. It is coming into the pair. So first pair, second pair, third pair, fourth pair, 5 pair, and 6 pair. 6 2 is 12. So total there will be 16 hexadecimal numbers, and these 12 decimal numbers are enough to represent. I think at this instant it can give uh, like 10 times the world's today's population. So we can have as many as devices with the unique MAC ID, because MAC ID should not be repeated. So this is why we use this 12-digit hexadecimal MAC ID. So that thing is related to IP addresses and MAC ID, right? Now we'll talk about what is IPv4. So very first thing is IPv4. So we talked about the numbers. Okay, so how do we represent the numbers, and what is IP protocol? So header, these are the headers. I'll go to that header later on. First we'll talk about this IPv4 addresses. So very first thing we are already knowing that IPv4 or IP addresses is of 32-bit long. 32-bit in the binary form. Binary form, that is in numbers. If I take 32 bits are there, and one bit is capable of representing at least two different values. So how many total values will be there? That is calculated as 2 power 32. Means 2 you multiply 2 every time 32 times. So 2 2 ja 4, 4 2 ja 8, 8 2 ja 16, 16 2 ja 32, 32 2 ja 64, then 64 double is 128, then 256, then 512, then 1024, then 2048, then 4096, and so on. So if you keep on doing that, you will end up with this much value. How much is this value? This is approximately 4 billion. So these many number of IP addresses are possible, and these many number of unique IP addresses are possible. Each IP address will be different than this new IP address. So total there are these many number of IP address. Okay. So from this IPv4, so that is there. Okay. Now next thing is that it is divided into set of 4 different dotted decimal notation, set of 4. So 8 bit, 8 bit, 8 bit, there will be 4 set of the values. So one set will go up to 255 from 0 to 255. Okay. So earlier in this IP we have shown that there is 8 8 means dot dot dot. So there will be dot which will divide the 32 bit into 8 different set. So 8 bit, 8 bit, 8 bit and 8 bit. So first 8 will go up to 0 to 255. Second will also go from 0 to 255. Third will also go from 0 to 255. And fourth will also go to 0 to 255. Means in each of the set, none of the number will go more than 255. So some examples are mentioned here. Everywhere numbers are there, but they are not going more than 255. Understanding this? Any doubt or any other explanation do you need with this IPv4? Is it okay to understand now?
Yes.
Okay, so whenever we assign or we get or we see any IP address, we have to know that the IP addresses can range up to 255 after a dot. So for with every dot, it can go maximum up to 255. So the lowest number is 0.0.0, that is the very first IP we can say, and highest IP address can be 255.255.255.255. This is very huge range actually. So this is from all 0 to all 255, that will come out to be this approximately 4 billion numbers. So these many different IP addresses will come in that range. Means the next IP address will be 0.0.0.1, then 2, and then 255. Then after 255, second set will become 1, then again it will range up to 255. This is like number system that when we start reach up to 19, then it next number is 20. So 9 becomes 0 and 1 becomes 2. Same way here also 255 becomes 0 and next 0 will become 1, and this process will continue till all 255. This is possible. So this is called as IP address for representation. So whenever we want to represent that IP address, we can use the octet also or the numbers. So this is hexadecimal number. We'll again come back to when IPv6 is there. So the number which we were talking about are the IP addresses. This IP address is actually belonging to this IPv4. Okay. Yes. So from the network layer, that is the third layer in our OSI model, there this IPv4 protocol is used. So IPv4 protocol is actually onto the third layer of the OSI. Third layer of OSI model. So I have already told that it is 32-bit long. So 32-bit means from here 0 to it will go up to how much number? 31. So this is up to 31. And in that first 4 bit is represented is reserved for versioning, then IHL, then there is TOS, then total length, then identification is 16-bit, flag is of 4-bit, then there is a fragment offset, then time to live TTL, then protocol which is used, then header checksum, and after that source address is there and destination address is there. Let's say my packet is going from one IP address which is actually 192.168.0.3, and it is to be delivered to 192.172.0.1. So one number is acting as a source and another number is acting as a destination. So the details are over here, that which bit is there, which is acting as a what and all. So we should know certain things, like from TTL. So TTL stands for time to live. Okay. So time to live is very important factor over here. Why? Because time to live represents that after how, till how long your packet will survive in the internet. So time to live. So time to live represents the maximum number of hops that a packet can take. So now this is very important factor even for the network security as well. So every router when receives an IP address, it checks the source address, destination address. It understands what I'm just explaining the job of router. So router receives a packet which is having its own IP address, where source IP address is mentioned, destination IP address is mentioned. Router understands that this packet is to be forwarded to this location, and that location can be, okay. So location is maintained there. Just a minute. Okay. So yeah. So now we are talking about this TTL. So time to live. So again, for the security aspect, every router when receives this IP packet, what it does is it reduces the number of that 8-bit number. Means how much is the maximum hop possible? Can anyone tell? If 8 is there, then how much is the maximum hop possible? 2 power 8. So that is 256. So 256 hops are possible. Means 256 time it can hop. So every max, this is maximum number. So every time whenever packet is sent, it is assigned with some TTL, time to live. Let's say I know that my packet can reach to a destination in 8 hops. So I will put 8 hop ongoing, 8 hop returning, total 16 hops. So 16 hops is there. So every time in between router when they receive, they decrement that counter by one value. So if it encounters first router, it will make that number as 15. So 16 is the TTL number. When it receives at the first router, number will become 15. And then second router, number will become 14. And it will keep continuing its journey. And let's suppose at destination, it should reach within this 16. Actually 8 hop is there, but maximum double is there. Let's say it may take some other path or other routing, then maximum up within 16 it should reach. But in between, let's say at any router, if the hop count is becoming 0, then that packet will be discarded. Packet will get discarded. So this is the issue now. So that is why we have to in every IP it is checked properly, that how exactly packet will be sent to the next destination. But if that value is becoming 0, then it will not be taken forward. So that is why this IPv4 is having all these things in place. Okay. Then there is source address, destination address, and then there are the options and the padding. These all these called as padding. Padding means extra thing. So even if very less data or no data is there, then also at least 20 byte of packet size will be there. And if any extra thing is there, then your packet can go up to 65,000 byte of data. So this decides the overall size of the IP packet. So minimum IPv4 is having how much byte? 20 byte of data. One layer is of 8. So 8 fives are, one layer is of 32 bit. So 32 bit, 32 bit, 32 bit, 32 bit, and 32 bit. If you add them all, divide by 8, you will get 20 bytes of data. So that is the things related to the IPv4. Okay, so you can just take the means later on you can just understand that how IPv4 works. Okay, so there is a lot of resource, animations, videos are also available. So I request everyone to if you are feeling that you need to know more about IPv4, you can just go ahead with this IPv4 understanding. Okay. So similarly, I have told you that IPv4 is there, but then there is IPv6 as well. IPv6 is actually a new IPv6 which has started coming into the practice, and now this is the replacement of IPv4. So in the background, already there is IPv6 running. So IPv version 6 is actually having 128 bits instead of IPv4 was having 32 bit. So you can imagine the number of addresses which are possible to power 32, which was approximately 4 billion. And here you can say check 2 power 128, which is very, very huge number. So it is having very large number of unique IPv6. Why is it required? Because nowadays internet has evolved so much that every house or every corporation, every organization, they need plenty of IP addresses, and now fulfilling those requirements with IPv4 is very difficult. That is why people are moving on to IPv6. So this is already done in the backend, and but whenever you go and search or ping for any command that we are going to see, so there you will understand that you are having this particular IPv6 also present in that. But in the front end, still for understanding purpose, we are using IPv4. So IPv4 is actually just placed here. Otherwise, IPv6 is now running, and all the IoT devices are there. They are strictly using IPv6, not IPv4. So if you are into the security, network security, which involves the IoT devices as well, then you should know what is IPv6, how exactly it works, and what are the other the factors will be very much similar to the IPv4. Okay, so this is for utility. Multi access is possible. It is having more attractive because number of fields are more, so you can add up more options there. So more uh, options or more setting options can be there. Controls are more, and then address space is very huge. Okay, so it is like many fold of the even world's population. So considering one person is using 2 device, so then 10 device, then also you can get those many unique IPs. Then potential socio-economic benefits are available because internet is evolving. So all the internet, if they're nowadays you can see uh, we are actually into online meetings, so it is a kind of LAN connection we are into. So like ubiquity of the internet is maintained. So this is the these are various advantages of IPv6. So one can always go and contrast and compare that how IPv4 is there, how IPv6 is there. So this is the packet format of IPv6. So just as a basic, whenever any interview is there or any understanding is there, so sometimes they can ask that what is IPv4 or 6? Do you know certain packets and how exactly they are there? So at least this is the basic things that you should know from the IPv4 and 6. So uh, just read and just understand that fields which are there, and that's all. Okay, no need to mug up or remember every time, but at least you should know that what is this IPv4 and 6, what are their advantages, how are they different. So this is the compare and contrast between the IPv4 and IPv6. As you can see, this is only 20 byte and this is having huge address space and lot of fields are there, and hop count limit is also more here. So if you want your packet to survive more into the internet, hop count or hop limit, which is called as TTL in IPv4, and in IPv6 we say them as a what, hop limit. So that can be done. So hop limit is here, and here we have TTL, time to live. Okay, header checksum is there, which is actually adding all these numbers together, and then you invert them, and then that is another code that you get, and then you add that along with the header. Whenever your packet is received at this receiving end, they always check this checksum or header. Once they check this header or checksum, they understand if that gets correct, it means your packet is received correctly. So this is one sort of check which is ensuring that the packet or header or the internet packet which has been received at that destination is having no error in that. So these are the things that is related to the IPv or IP addresses. Okay. So is there anything that you want to ask, or then we can go ahead further? So IP addresses we covered just now. So IPv4 is there, IPv6 is there, and this is the compare of the IPv4 and 6. Okay. So is there anything you want to ask? Then we can proceed further. Then we can go with the IP commands, which is helpful for the network security. How do we ensure, how do we do certain findings into the via IP addresses? Can you confirm?
Yes, from my side.
Yes,
Okay.
from my side too.
Yeah. Okay. So then we are good to go further with the. So we know something related to IP addresses now. We know that IPv4 is there, IPv6 is there. That is okay. Now we'll need to know that how can we diagnose the internet, or whenever we want to diagnose, or when we want to check, we want to investigate, all these are for the to for the security purpose. So network security generally involves going deep down and understanding what is happening in the packet, how is packet is flowing, whether host is alive or not, whether host is pinging, whether you are able to reach to the host and or destination. So all these security thing demands certain kind of commands which can be used along with the IP address. That is why we got to know with the IP address. Now, very first command that we need to know is called as ping. So, pinging of the IP address. So, how do we ping anything? Ping is a command which is actually for the testing of the reachability of the host. So, whenever any host is available in the network, we can ping out. So, whenever we try to ping out, we have to use the website name, but we are, or more frequently we are using the IP addresses. So it means you should be knowing what is the IP address of the destination, what is the IP address of the source, or source means host, and the destination. So if I want to check XYZ PC is there, so I can ping that, but that is in case of LAN or smaller network. But whenever I want to ping for certain websites, or I want to check if anything is there on the server, whether it is active or not, whether that server is up or not, So I can also ping there also, but at that time I need the IP address of that. So there are certain private addresses and there are certain public addresses. So we should also know what is private and what is public addresses as well. Okay, so uh, like we have the categories of the private and public addresses. Okay, so does anyone know the difference between private and public address? Can anyone confirm? Then we can proceed with the commands. So can anyone just highlight what is private IP, what is public IP? Whatever you understand, just can tell. Mhm. Any idea? Public and private IP address. Okay, then we'll keep we'll cover that topic also. No problem. So ping is the first command that we need to use along with the IP address that will check whether host is alive or not, or reachability of the host. Okay. So if you ping any computer, which anything which is present in your network, you will get within the network, you will have that IP address. You need to have that IP address. Similarly, for any websites, let's say you don't know the IP address, you know the website address, you can ping that also. So that is first thing. Second thing is about what? About IP config. So this is another very important tool, that important command that we need to know. How do we check our own system's IP address? So that is done by using this IP config or IP config slash on. Okay. So this is what is there. So IP config helps you to understand the IP address of your system. So I hope you all have sometimes seen the IP address of your own computer, or sometime it is required, or servers which we are using. So we should know that what is the IP address our own server. So all these things are there. So I'll just show you how exactly we are using it. So let's say I'm going into command window. So this is the terminal that we are having. This is called as command window. And in the command window, we are going to use the IP address. So I want to know. So I will type which command? ipconfig. Okay. So in the Windows PC or Windows Server, there you can type this command, which is called as ipconfig. But in case of Linux server, you have to use ifconfig. Similarly for Mac OS. So when I press enter, as you can see, there is like details which are available, right? So similarly, we can have the ifconfig and ifconfig all. So even yeah, I can go with ifconfig all as well. Okay. So what details will it provide? It gives the computer's IP configurations. Sorry, I'll just make this screen bigger. It will display the IP configuration, which will have the IP addresses, actual IP address, then what is the subnet mask of that IP address, and the default gateway of the IP address. Default gateway is another IP address, which is actually our own IP address with no host number. So it will suggest that whenever your packet is about to go outside of your computer, then which IP address should be utilized, where that is related to the router which is connected. So that is your default gateway. Like in one bigger complex, or one bigger you can say residential area, there let's say there is a common gate. So that common gate is actually the default gateway. So by default, everyone has to enter or go out of this gate whenever they want to go outside this network. So if I want to go outside of this network 1 and I want to go into the network number 2, so I should be using which IP addresses? Default IP address, which is allowing this communication. Here in the network there is lot of different computers are there. There is communication between each of them within also. But if any host is there in A, which is part of network B, and here I am sending from X to A, then I should be using this default gateway. So this is where the role of default gateway comes. So few terms will be there that will come along, and I hope you all have already heard this name. So whenever you are in doubt what is this, immediately you can check. So for today you can spare like half an hour more after the training, or maybe before next training, so that you can understand what are these things. You just try to understand what are the things, because the more you try to search, more you try to go with the concepts and the more fast or easily you can get the concept of all this. And this is only one time study. One time you read, you will understand, no problem. Next is the trace. So trace root is short as a tracer. So trace root, you can also type both of the commands. Whenever I type this trace root command, and if I can use any IP address or trace root with any uh, website name, what will it give? It is going to show me the various routes that packet is going to take. So whatever are the in between routers, even those IP addresses, those hops is also available. So sometime if host is not active, you are not able to reach to the destination due to some attack, due to some issues, due to some problems. Then you can also understand till what level your packet is going, what is the reachability of your packet. So let's say your packet from source to destination, your packet is taking three different hop and then getting delivered. So this is router number 1, this is router number 2, through which your packet is going on. So what is to be done? So you can use trace route. Even when you ping, you will see the source and destination, but when you go for trace route, you can get R1 and R2 IPs as well. So this is what is the trace route, or details of R1 and R2 trace route is going to give you. Similarly, there is one more important command that we should understand, is called as netstat. So netstat is also very important thing, because for security purpose we need IP address as well, we need the listening ports and the routing table. So ports are very much important thing. What are the ports? Ports are nothing but the opening point or windows which is present in a computer. Like we have in the laptop, we have physical ports. They are called as there are different type of ports. If I say there is USB port, there is Ethernet port and all these. Similarly, whenever we talk about the network, inside the operating system, there is also ports. So these ports are having number system, they are having their own numbering system. So whenever any communication is going or packets are coming in your computer or in your endpoint, what is going to happen? It is going to get delivered to respective port. So for internet, there is port number 80, there is port number 443. So whenever any packet which is actually having internet level or IP packet is coming, they will be delivered to the port 80 and port 443. So whatever application in your phone or in your laptop is having that enabled port, they only receive that. Similarly, some other ports are also there for the file transfer, for the network and all. So we are going to see that also in the details. So what is port? Port is nothing but a window or opening or accepting connection of the packets which are inside the operating system. Okay, every time whatever device is there, they are going to have some ports. So all these details will be available with this command. So if you use this netstat dash a or netstat a dash a means all, it will show you the all things which are into the findings, all listening ports, routing table, everything. So this is netstat as the next command. Then fifth command is there, nslookup. So we can use these commands while trying to investigate something, trying to understand the security or trying to go with so see whenever I'll just deviate and tell you something else here. So whenever we are into network security, the very important part is that we should understand how this network is working. Is there any possibility that network can be penetrated, or network, so network penetration means hacking. Okay, so without authorization, can I go into the system? So that is what is the hacking or penetration is. So whenever we are trying in network security, there is people are doing, or every organization who is having good cyber security team, so they are actually having these kind of practices. So one is called as a red team and one is called as blue team. So red teams are what? They are the attackers. They are deliberate attackers. Okay, they are authorized ones, but they try to intrude in our own system without any authentication or authorization. Like, I want to check whether I can enter in my home without generating the alarms or forceful entry. Is it possible? I just want to check the security of my own house. So that is the part objective of the red teaming. Then there is blue teaming as well. Blue teaming are the defenders. So defenders are what? They will be active whenever any kind of attack is happening. So this drill is performed. So whether attack is going on, then how defenders or blue team will react. So and after mitigation, once they get the mitigation, then they will go with the remediation. So these are the steps that is getting involved. So this is common practice everywhere. So that involves network security as well. So that is why in the network security we should know these commands. We should understand what are the issues, and these commands are very handy whenever you want to perform all any activity, either red teaming side or blue teaming side. So fifth one is the NS lookup. So again, NS lookup is what? It is going to give you the information related to the websites you have asked. So it is nothing but the query to the DNS. So what details you are going to get with this NS lookup command? You will get the domain name of that, IP addresses, and other DNS record if it is present with that. So these are the things related to the NS lookup. All these commands are there. That is possible. Even you can check in your own computer. Even you can like uh, use any install on any virtual machine, and you can do that there also. You can do it in Windows, you can do it in other operating system as well, like Linux or Mac. So you can try these commands as well. Okay, any doubt or anything you want to ask? So next things are related to further commands, which are so you can practice these commands as well. Okay, because I cannot show you everything from my own system. Okay, because again the security issues are there. So uh, I have shown you how can you run this into the CMD. Same thing you can also do. So there is IP config, or then there is a NB stat. So NB stat again with the, which will show you the net BIOS as well. Okay, so TCP IP another part.
Um, I have a question here.
Yeah, please go ahead.
Yeah, so the first IP config and this one is different.
No, means IP config if you are using it is same. Okay, but here we are using flush DNS as well. So which is helping Sometime what happens that if it is a forward slash with that, okay, ipconfig forward slash plus DNS, right? This full thing is as a command. Are you getting this?
So both are same.
No, no, this is further ipconfig slash plus
Okay.
DNS.
Two
This,
different commands. Okay.
this is one complete, okay, it is further
Yeah.
thing.
Okay. Okay.
Okay,
Got
so
it.
what is flushing the DNS? Flushing DNS means sometime beeping something, but what happens that DNS may have got new entry, it has changed, but I'm still using the old DNS record and I'm trying to find out certain website, but it is not reverting, it is saying there is DNS or error for 500 series error. So then we can use this flush DNS command. So it will flush out any entries which are coming, which is there from the DNS. It will be flushed and refreshed again. So then we can get any new changes which may be there in the DNS. So that is how this command works. Then there is a nbstat as well. So nbstat is actually for the net bios. Okay, so whenever we use we want to know any TCP IP informations of the net bios, we can use that. Okay, not all commands are always used, but all these are the available commands. Similarly, there are plenty of other commands as well. Okay, so there are the like basics of Linux. So in that you'll understand, you can understand all the commands and everything, so you can refer those topics as well. Then route print is there, which will display or modify the local IP routing table, and with that you can at least understand that what are the entries available with our table. So netsh is another versatile command that we are using. It is again another important command that we have. Okay, that is showing the various configurations of the network related setting. So netsh, if you do, you will get the all the interfaces. Interfaces means what? If you have a router, then it will show you how many other networks are connected with your router. If you are a part of a LAN or two different LAN, it will also show you. Let's say your PC is having Ethernet cable or router or Wi-Fi or Bluetooth or any other things. All the interfaces will be shown who are having this IPv4. So this is what is available actually under the commands. So there are several other commands also available. So if you want to know that how packet is flowing, which packet is there, and what is the network interface, and how in the running, if any network is up and running, then how can you capture any packet which is flowing in the network. So let's say you are in that particular network, you are connected with the Wi-Fi or the LAN, and then you want to check what people are sending, what TCP packets are there, even you can check those packets. So that is done by using this tool which is called as Wireshark. So Wireshark is one of the tool. Similarly, there is one more Soft Packet Builder. There are different tools are available, but these tools are helping into capturing and analyzing the network traffic. So sometime it with this someone can even exploit the network. Even can, if we are not using secure communication, so our packet may be traced, and then if I'm not using HTTPS, I'm using only HTTP, so their information is sent without encryption. So at that time anyone can read whatever you are sending in your data part. So this is these are the this is one of the tool which is the very first tool which is helping into the network security. or it is also giving you the graphical interface also to understand the in-depth network analysis. So many times network engineers are using this Wireshark, and they are populating all the details on their screen, and then they can use certain filters, they can do some analysis and all this. So that is related to the Wireshark. So we can do some activity onto the Wireshark as well. So that is our next goal actually. So in the Wireshark, we have plenty of commands to run. So the commands which you have already seen. So some of the Wireshark commands are highlighted over here that we can practice. Okay. So there is like IP addresses we want to know. So we can just use that. Port number we can capture. TCP dot port equals 80. That suggests that I want to capture the TCP packet whoever are actually available at port number 80. Why am I going for port number 80? Because port number 80 is actually for the internet. So port number 80 and port number 443 both are there. So 80 and 443. So port number 80, port number 443, but port number 80 is unsecured port. So here there is no encryption, and this one is encrypted. So here, even if you can see the data of the user from this packet by using this Wireshark tool, but still you will not be able to make the sense of it because this data is encrypted. So these are the things related to network security, where Wireshark is a very like a famous tool, and people are using, and these are the several commands that is there. We can practice this onto the Wireshark as well. So IP address, port, protocol, you can even combine the conditions, like I want to check for IP address this, and I want to also check this. So you can combine them by using this and command. So two conditions will be checked together. So this is how we can concatenate the different commands together. Is it okay? Then there is display specific tool. I just want to see what are the HTTP commands, are HTTP packets are there, or I want to check the data. Let's say in the network there are many devices, and all the packets are, all the data we can see, but I want to check only the packets which are actually there in the network because of the host number 192.168.1.1. So that is also possible, we can filter it out. Or we can also display by subnet. So subnet, whenever I say subnet slash some number is there, you have an IP address, let's say 1.1.1.1 and then some slash number. So whatever is the slash number is there, 24, 25, 28, up from 1 to 32, whatever number it can come. So whenever you have this kind of slash value, they are actually representing subnet. Means this will give you the range of IP, range, certain range of IPs will be there. And those IPs means all the range of that IP's data packets will be available in the Wireshark. You can filter that out. And if you are interested to see only via these range, because most of the time, let's say if hacker or any particular attacker wants to target any organization. So or any organizations is having bunch of IP addresses. There are plenty of IP addresses. So bunch of IPs are there. So what there is like something 192.168, all these are some IPs are there. So all these IP will have one thing as common. What is that? Slash some number. So your IP address slash some number will be there, and this slash this number is actually called as subnet, and this will provide this all range of IP address, all range of IPs. And if you know all range of these IPs, then you can even target that particular organization, particular home, particular house. So whatever uh, devices are there, all those packets we can get. Okay, but there is one condition that your Wireshark should also have the access to that entire internet. Okay, so it should be there within the internet. So if it is, depends upon the kind of system you are using. Similarly, you can filter even with the MAC address. We have discussed this. MAC address is which address? Physical address. Physical address is there. See, physical address is there, that is hardware address actually. So hardware address is there, it is not changed. So for every computer, every PC, you can see that Ethernet address, and these Ethernet address is also there in the Wireshark, and we can search it out. We can just do what? We can select the MAC filtering. Similarly, there is DNS filtering possible. There is a if I want any input method, let's say sometime we request data from the website, so that is what the get request is there. Means if someone is accessing something, even I can snoop in that. That is called as get. However, I will not be able to get what is being taken or what information is there if it is, if the data is encrypted. If it is not encrypted, like within the LAN, if we are doing something, chatting and all, so then that can be easily uh, exploitable. Then we can also filter by source and destination. So you can directly put the source IP is this, destination IP is this, and now you tell me what are the packets going between them. So that is also a feature of the Wireshark that one can get. Similarly, you can use certain ICMP. ICMP is Internet Control Message Protocol, which is for the setup purpose. So we can use this IPMP as well. Then there is virtual LAN. Let's say if someone is using virtual LAN, you can also filter it out. We can also check for long messages, long packets. So if frame length is more than 100, let's say only those messages you are interested in, because user data, when it is adding, then only message length will increase. If message user data is very less, or it is not there, or any control message is there, that length will be lesser than 100. So why to take all those traffic or all those extra crap, okay, if it is irrelevant to us. Similarly, we can filter out by time range as well. Time range means we can set up that from this much time to this much time, 30 millisecond to 60 millisecond. Within this span, whatever are the packets or whatever is the data, just filter that out. So even we can use that by using the Wireshark command. So this Wireshark tool is there. You all can also install in your computers and can practice this. Okay, I'll show you certain demonstration onto Wireshark as well, but you can also install and check it by yourself. So these are the different commands that is available. Similarly, for the Windows, we can use these different commands. Okay, so that is also possible. Ping, you just type ping command. These are the extensions. So you write, okay, let's say you write ping dash n and then the IP address. So this will be for this particular command. Similarly for others, let's say if you type ping dash t, so it will specific host, it will keep on pinging continuously. You will see that how much packets are coming in. Okay, so that is ping command. Okay, so all these demonstration, all I'll show you into the uh, command into the command window itself. Okay, so even you can also practice this. So these are the various things that you can take the screenshot and you can try by yourself also. So this will give you a better hands-on onto the network things, that how exactly you should know that how IP address is there, how I can check the IP address, how to know the IP address, what are the subnet mask, default mask of every particular IP address, how to know what is the time to leave, TTL, that I explained. So what is the time to TTL, time to leave for this IP address what I am using. You can get that information from this. Similarly, all other activities you can perform. Okay, so at this instant I'll stop for today, and in the next session I'm setting up some demonstration activities that will be onto the commands and the wireshark that will complete our network security part, and some SOPs will be there how to use certain things in a specific way. Okay, anything, any other doubt, anything if you want to ask, you can go ahead then. Did you all refer the recording?
Yes, I did.